No, yeah, I like to tape you guys. Yeah.
Can I get a drink?
All right, so here we go. So we've written down the pattern for the geometric sequence. And let's see if we can actually find what the ratio is, what the pattern is. Now, unlike the arithmetic sequence where the adding, that was kind of easy to figure out. The geometric one can be a little bit more difficult because it's multiplying. And you're not familiar, if we multiply by a fraction of some kind, it may be difficult for you to figure it out. So, if you will take, and this is just my suggestion, the last number in your pattern, which in this case is 384, and divide it by the number that's previous to it. So 384 divided by the 96 gives you an answer. 96 divided by the 24 gives you an answer. If this answer is consistent, it is a geometric pattern, and we say the ratio is 4. In other words, what are they multiplying by each time? They're multiplying by a 4 each time. Does that make sense? Okay. Now let's look at the next example to see if there is a ratio on this one. I have 115, 110, 105, and 100. I'm going to find out if they're being multiplied by anything. So I'm going to take the 100, which was the last term, and divide it by the term that was in front of it, and I get 20 over 21. 105 divided by the 110. Uh-oh, 21 over 22. Were those the same ratios? No, so this is not a geometric sequence. So let's check it to see if it's an arithmetic sequence, or maybe it's neither. We'll have to figure it out. It says the ratios are not constant, so the sequence is not geometric. So now let's see, am I adding or subtracting something? I'm subtracting, so technically I'm adding a -5 each time, right? So would this be considered an arithmetic sequence? If I'm adding the same amount each time? Yes. Yes. Okay. So this is an arithmetic sequence, and the common difference, in other words, what I'm adding each time, is a -5. The first part of your assignment is going to ask you, tell if this is a geometric, an arithmetic, or neither, because that could happen. So let's try that over here on the side. See if you can find out what type of sequence this is, and either name the R value or the common difference value. Okay? So see if you can do the math to find the R value, if there is one. Just like you did in the notes. Yes, sir.
3.
Show off. Okay. Okay, so, all right. This one was fairly easy to find out that I was multiplying by 3. It was pretty consistent and pretty easy. And since it was multiplying, it is a geometric, right? And my R value was a 3. The ratio was a 3. We good? All right. Let's go to the next one.
It's arithmetic.
So I'm adding 6. I'm adding 6. Ruh-roh. Okay, so it's definitely not adding the same amount each time, is it? Because I went 6, 6, 8. That sounded like Duck, Duck, Goose. Okay. So what about 22 divided by 14?
It's 11 over 7.
Okay, cool. It's 11. 24. There should be a 14. So that becomes 11 over 7. What about 14 divided by 8? Divide by 2, I get a 7 over 4. Are those the same? No. So it wasn't arithmetic. It wasn't geometric. So this is going to be a neither. Good. All right. Now let's see how to find the next 3 terms in a pattern. Shouldn't be very difficult. Go down to example 2 in the notes. It says, find the terms of the geometric sequence. Okay, they're telling you it's a geometric sequence, so you don't have to wonder. You know it is. So we just have to find what the common ratio is. So 686 divided by 98 became a 7. Since they're telling me it is a sequence, I don't have to check the next ones. I just have to find one of them. So I found a 7. That means to find the next number in the pattern, I take the 686 and multiply it by 7. I get 4,802. I take 4,802 times it by 7. I get 33,614. I times that by 7 and get 235,298. You will be getting very large and or very small numbers on this assignment. You will get some decimals, so don't think you're doing something wrong, okay? Okay, let's look at the next example. Did everybody see that was pretty easy to just multiply by whatever it was? Your calculator's going to get a lot of work. But what's different about this problem? What do you notice? Yeah, it's
There's
getting
two
smaller.
negatives and two positives.
Okay, it's alternating negative, positive, right? So what does that tell you possibly about what you're multiplying by?
Multiplying by the same number. It's going to be
Multiplying.
or something going to be negative.
Yeah, it's probably going to be a negative number because a negative times a negative would make a positive. Then a positive times a negative would be a negative.
Negative.
So it becomes a positive again. So when it's alternating back and forth, it probably is going to be a negative value that you have to multiply by, okay? So let's find it. We would take the last number and divide it by the number in previous, in front of it. So 8 divided by the negative 16 became a negative 1/2. So I know that my common ratio is a negative 1/2. If you want to put a negative 0.5, that's fine. Make sure you're using the baby negative sign down by the enter button to do the negative 0.5, okay? All right, so, and we need to make a correction here because someone evidently made a mistake. That someone would be me. 8 times a negative 1/2 is a negative 4. Negative times a negative is a positive 2. Half of 2 is a 1. This should be a negative 1, okay? All right, see if you can do the try-its there. It says find the next 3 terms. So see if you can figure out what the ratio is, and then find the next 3 terms. Tell me what you get for your R value. Negative 5, good, okay. So now you just grab your calculator and go crazy. Oh, too fast. Oh, I hope that's right. Negative 46,875?
Yes.
Wow, that seemed too quick, huh? All right. Are you good with this idea? Sweet. See if you can find the ratio on the bottom. Try it B there. Again, start at the back. 81 divided by the 54. What'd you get? 1.5 or 3 over 2. So doesn't matter which one you use, they're the same value, okay? So my R value is a 1.5 or a 3 over 2, whichever you prefer. So 81 times 1.5, 121.5 times 1.5, 182.25 times 1.5, 273, 375. We good? Okay, sweet. Has this been overly difficult?
Not.
No. Okay, so that's why I say most of it's pretty straightforward, all right? So now I'm going to, on the back, I'm going to explain and kind of walk you through the examples on the back. And you're not going to have an issue with this. It's really not going to be too bad, I promise.
So we're just doing like
I mean, well, it's new to us, but it's familiar to you because you've done it similar before. That's why it's not overwhelming to you. You're somewhat familiar with it. All right. Remember back when we were doing the nth term of the arithmetic sequence, you had to build that equation first. Well, you're going to do the same thing with the geometric term. So you're basically going to take the formula, plug in the information that you can get from the numbers that have been given to you, and do the math on whatever it is they ask about. So if I have this pattern of numbers right here, 2, 6, 18, 54, and they want me to write the equation for the nth term, that means I need the equation that actually has an n still in it, so that someone else can come along and go, hey, find me the 300th term, and you can plunk a 300 in and go. So let's see if we can build the nth equation. So the first thing we have to know is what our a value is, because this is the pattern, this is the formula right here. I know it's a little faded, I apologize. All right, so we have to find the first term because that's the a value. So what is the first term?
2.
Whoa.
3.
The 2, okay, the first term is a 2, so the a value is going to be a 2, okay. The common ratio would be the next thing that I have to find, so 54 divided by the 18 is 3, 18 divided by 6 is 3, so my r value is a 3. This is your answer to the nth term, all right. This is the equation, nth equation. Because now if somebody came by and said, hey, find me the 300th term, you could put a 300 where the letter n is and you would know the answer. Okay? Let's find the 13th term. Let's find the 13th term here. So we would put a 13 where the n is. We subtract 13, take away 1, we get 12. And here's the important part. Please pay close attention. You're dealing with exponents. Do your exponent math first. According to the order of operations, I have to do 3 caret 12 first. Then I can multiply that answer by the 2. That's huge. Make sure that you do it in the proper order. And then you get this ridiculously huge number of like a million something, 62,882. Let's look at the right-hand side. Here's our new pattern. It is a geometric sequence, I'm telling you that right now. But let's come up with our own number that we want to find. So let's build it first, and then we'll come to a consensus on what we want to find. So if I had to build the nth equation, we would have a to the n equals, what would come next? 96, because that's my first term. And I have to find my ratio. So 0.5, 12 divided by 24, yep, that's a half, so 0.5. And it's raised to the n minus 1 power. Sweet! Now, I'm telling you right now, don't use the number 2000. That's what first hour wanted to do. It's crazy! Okay, maybe something a little smaller than a 2000.
okay. 1,900.
No, that's still gonna, it's still gonna make our calculator go nuts.
2.
Huh?
2.
50?
15.
15?
7. 22.
5.
56.
56! I wanted it to be ugly. We need it to be a little bit ugly just to have some fun. Okay? Alright, 57, which will turn out to be 56 in the end, but not really. Okay, let's put in a 57. That's my age, I like that. Okay, 96, for real, yeah. Okay. Gee, thank you, A for you. Alright, 57 minus 1. We're finding the 57th number in our pattern here. Now, look at this number. Look at these patterns. Are these numbers getting bigger or smaller? What?
Smaller.
So this might be a really, really, really tiny number, right? Okay.
It's not.
Oh, yeah, it is. Uh-huh. All right, so 57 take away 1 becomes 56. And remember, I have to do this part first. You have to do that part first. So 0.5 caret 56. What? Okay. 96 times 1.387777878 times 10 to the negative 17. What? That's ridiculous. Yes, sir.
Why are you putting, like, where the A is? Why are you making the N smaller than the A?
Because it's not an AN, it's A. Because in the formula, this is just representing the pattern. I'm looking for the value, and this is the term. And it's a subletter, okay? All right, so if this has a negative 17 for the exponent,
There's still more.
there's like a whole bunch of zeros. If I were to change that to standard notation, I'd have 16 zeros in front of this little sucker, okay?
That's done.
But now I have to times this answer by 96. So let's see what happens. Times 96.
Oh.
It got better, didn't it?
Yeah.
Only by a little.
Yeah.
So my final answer here is going to be 1.332266763 times 10. Now it's to the negative 15. That's so much better.
Not really.
Yeah.
But it's
Said no student ever.
But it's better than 17.
It is better than negative 17. So, my term, if I went to the 57th term in this pattern of numbers, would be this. So, I'd have 14 zeros out in front of that one. Yep. In my calculator,
I'm sorry.
did yours not give you a e to the 10th power?
After you carried it.
Yes.
Yeah, okay.
Yes. Does that make sense? Okay. All right. The last part's really fast, really easy. You have a story problem like this. This is no problem.
Why? Is it better?
It's graphing. It's super easy though and super fast, okay? Okay, so think about this. Sierra has a spring, and I use the name Sierra because that's my daughter's name, one of my daughter's names. Anyway, Sierra has a spring with a weight attached to the end of it. Think of a slinky, okay? And she's going to throw it over the edge of a table, and it's going to bounce up a little bit, it's going to bounce up a little bit, and a little bit less, a little bit less, a little bit less, a little bit less, right? Okay, each time it drops down, okay? So the first one goes to about here, then it comes back up, and the next time it only comes to about here, and then the next time it only goes to about here. Each time it's going to get a little bit less distance on it. This is, they're telling us that it stretches 75% of its previous bounce. So that would be our common ratio. That would be the R value, 75%. How could you write 75%? 0.75 would probably be the easiest way to do that. Okay? So you could also, so you can make it easy to use. That's fine. Now, you're going to have to graph this. That's easy to do. We have our X and Y.
Bless you.
Okay. Now, is the distance going to depend on which toss or which bounce it was? Or is the bounce going to depend on the distance? Which one's going to depend on which?
Distance is
The
better.
distance is going to depend. So Y depends on X. So this is going to be the distance. So the distance is going to be the Y. And the time we try it is going to be the X. Each time we try it. So on the first try, they told us it went 24. Okay. On the second spring back, it went 75% of this. So we could times this by 0.75 and get that answer. What'd you get? 18. On the third bounce, it went 75% of the previous bounce.
13.5.
13.5. And we'll do one more and then we'll be done. 0.75. The fourth bounce.
10.125.
10.125. And so now all we have to do is graph this. the X goes across the bottom, and then the Y is going to go up the side. So at 1, I go up to 24. At 2, I go to 18. At 3, I go to 13. At 4, I go to a little bit more than 10. It's pretty easy. Your story problem is virtually the same idea. You don't get it? You okay? Okay, talk to me.
I can't really explain.
Oh. Okay, do you understand the common ratio? It's 75% of the previous one. Okay, so that's the main thing to understand. And you just multiply the one before it times that 0.75 to figure out how far it's going to go this time. Okay? Just think of it as you being more and more tired when you're shooting basketballs. You're at the free throw line or something. Oh, stop, be nice. So you throw the free throw, and on your 50th time, it went in. But on the 51st time, it went 75%. It didn't quite even make it to the basket because you were so exhausted. And then on the 52nd time, it only went 75% of that. So it keeps getting closer and closer to you. You're not throwing it very far. It's that same idea. It's less and less and less each time. Okay? So that's the idea behind this. And your assignments on the front of the page is 18 problems. They're even. And the beginning ones don't take you very long at all. You just tell whether it is or isn't a geometric sequence. And some of them you have to start finding the next terms, okay?
This is due on Wednesday.
Yes, ma'am, this is due when I see you again on Wednesday. So you have 4 days to get it done.